So types of crystalline solids. Okay, so how many types of crystalline solids we have? So what do we know now is what is a crystalline solid? Okay, a crystalline solid is one which we have a regular arrangement, okay, where the particles are regularly arranged, where they have a definite geometric pattern. So if we take crystalline solid, then how can we classify it? Now remember that any classification is based on something. So this classification is based on the constituent particle, means what a crystalline solid is made up of. Okay, what type of constituent particles? As I have told you, there can be many constituent particles. It can be atoms, it can be ions, it can be molecules. So what kind of constituent particle makes your crystalline solid? And how those crystalline solids or constituent particles are attracted to one another? What is the intermolecular force working on it? Okay, based on the binding force, which we say, and the constituent particle, crystalline solids are classified into 4 categories. Okay, so let us try to see. Based upon the nature of the constituent particles and the binding forces present between them, the crystalline solids are classified into following 4 categories. As I've told you, they are crystalline solid, molecular solid, metallic solid, and covalent or network solid. So these are the 4 categories of crystalline solid. Now the question is, what are the constituent particle present in it, and what is the binding force? What is the intermolecular force? So first, let us try to see it together. So ionic solid, the constituent particles is ions. Okay, molecular solid, the constituent particle is molecule. Metallic solid, the constituent particles are not metals. Most of the students go wrong over here. Okay, whenever anyone will ask what is a metallic solid is made up of, they always go for metals. It's wrong. Okay, they are not made up of metals. They are made up of positively charged metal cations. Remember that. Any metal is made up of positively charged metal cations, which we call them kernels also, and free electron. So if anyone will ask you what is the constituent particles of a metal or a metallic solid, your answer will be positively charged metal cations and free electrons. And the next one is covalent solid, which is made up of non-metals. Now the question is, what is holding them? What is the binding force? Now when we say ions, we know that it is positive and negatively charged, cations and anions. So obviously when you have positive and negative charge, the force of attraction is electrostatic force of attraction, okay, which we call as Coulombic force also. In case of molecular solid, okay, what you have learned in your class 11 also, in your basics also, that it is the van der Waals forces. We have many different kinds of van der Waals forces. So we'll try to see what are the different van der Waals forces operating. Then metallic solid, okay, are holded together by a particular type of intermolecular force, which we call as metallic bonding. We'll be coming into that in detail. And then covalent solid, okay, by the name itself, it's covalent bonding, okay, sharing of electron. Below you can see some examples, okay, like the first one is nothing but example of ionic solid, sodium chloride. Then you can see on the right hand side, ice, water, okay, molecules. So basically it's an example of molecular solid. Then you can see examples of metallic solid. I don't have to tell you, okay, metals. And finally, example of covalent solid. One of the very common example is diamond. You can take graphite also, but diamond is one of the most common example of covalent solids. Okay, so let us try to discuss one by one all these different kinds of solid. Okay, so first, let us start with ionic solid. So what is ionic solid? By the name itself, in this solid, the constituent particles are positively and negatively charged ions. So in this solid, the constituent particles are positive and negative ions, cations and anions. These ions are held together by strong electrostatic force of attraction. So these ions will be held by strong electrostatic force of attraction. Negative and positive will attract each other by strong electrostatic force of attraction. Because of strong electrostatic force of attraction, they have high melting and boiling point. Always remember that ionic solids have very, very high melting and boiling point. Okay, very high. Why? Because they are holded together by very strong attraction. Okay, very, very strong electrostatic force, which becomes actually very, very difficult to just break, okay, or to actually put them or separate them. Okay, the intermolecular force is so strong that they are holded with one another, so close to one another, so strongly that you require very, very high energy to separate them, okay, to break them into or to make them into a liquid or melt them or to bring them into liquid state. Okay, very important one, they are electrical insulator in this solid state because their ions are not free to move about. Please remember this. They are, okay, all ionic solids. See, what we are trying to say are they are ionic solid by the name itself. Ionic solid, ions. Ions mean charged particles. We know that when charged particles are there, then substance will start conducting, right? We know that. That is very common. When you have charged particles, it acts as a conductor. But even though you have charged particle in ionic solid, they are very poor conductor of electricity. They are insulators. Now, why ionic solids are insulator? Because although there is ions, these ions are static. They are fixed. They cannot move around. When they cannot move around, they will not be able to actually conduct electricity. In basic way, actually, definition of electricity is nothing but flow of charge. Your charge will not be able to flow. When charge will not be able to flow, how there will be electricity? How it can conduct electricity? So remember that in solid state, ionic solids are very poor conductor of electricity. They are insulators. But the same ionic solid, you dissolve it or melt it, then it becomes very, very good conductor of electricity. Now the question is, why they become good conductor of electricity in aqueous state or in molten state? Because when you dissolve it or melt it, they become free. When they become free, they can actually carry charge and conduct electricity very easily. Okay, just to make it easy for you, this is how we can understand it. Okay, so this is the solid state. You can see, so this solid state, okay, we can actually represent in this way. The cation is attracted by anion, anion are attracted by cation in the solid, and they are very close to one another. Okay, when they are very close to one another, they will not be able to move. Then what will happen is either we'll dissolve them or either we will melt them. Okay, usually when we melt them at a very high temperature, almost to 800 degrees Celsius, okay, it will melt if it is NaCl. Okay, then we can dissolve them. You can see water molecules, H2O, and then it will be free. Can you see in both this state what is happening is they are becoming free. When they are becoming free, what will happen? Obviously, now if you pass or if you apply potential difference, what will happen? The cation will move towards the negative end and the anion will move towards the positive end. There will be a flow of charge. When there will be a flow of charge, obviously they will conduct electricity very easily. That is how we can understand that why ionic solids are poor conductor of electricity in solid state, but very good conductor of electricity in molten or dissolved state. Okay, so remember that salt water is very good conductor of electricity, not salt. Salt in solid state is very, very poor conductor of electricity. Same thing when dissolved in water becomes excellent conductor of electricity. Okay, so that is how actually we can understand it. Then the next type of solid is molecular solid. By the name itself, molecules. So not actually molecular solids will be made up of molecules. But the basic question is, how many types of molecules do we have? So molecules are basically divided into two categories. We call them non-polar molecular solid and polar molecular solid. We have non-polar molecules and polar molecules. So I hope everyone understands over here. What do you mean by non-polar and what do you mean by polar? This is the basics which we do in dipole moment. Polarity of any system, whether a system is polar or non-polar, is decided by dipole moment. If a molecule will have a net dipole moment, which is not equal to 0, having a definite value, then it will be a polar molecule. If a system which will have dipole moment equal to 0, such molecules will be considered as non-polar. Okay. We will have one more type of molecular solid, which we call as hydrogen bonded molecular solid. Okay. By the name itself, where the molecules will be attracted to one another by hydrogen bond. But the question is, which molecules will form hydrogen bonded molecular solid? Remember that there is a basic criteria for a particular molecule to form hydrogen bonding. Hydrogen bond is formed by those molecules where hydrogen is attached to highly electronegative element which are small in size. Remember that, highly electronegative but small in size. For example, fluorine, oxygen, and nitrogen. So if you see any system, any molecule where fluorine, oxygen, or nitrogen, which are the three most electronegative elements, attached to hydrogen, then definitely these systems will be considered as, if they form solid, they will be considered as hydrogen bonded molecular solids. Okay, so if you see, if we can summarize it, constituent particles in nonpolar, it will be nonpolar molecules. How do we know which is nonpolar molecule solid? The correct definition is dipole moment should be equal to 0. Polar molecules, polar molecular solids, okay, and this will be nothing but the dipole moment which will not be equal to 0. And hydrogen bonded, they will be those molecules which contain hydrogen atom and which is bonded. Hydrogen atom should be bonded with electronegative element small in size, such as fluorine, oxygen, or nitrogen. Intermolecular force, whenever it is non-polar molecules, obviously in general we call them van der Waals force, but what do we know from our basic is van der Waals force are of many types. So if it is non-polar molecule, remember that the van der Waals force which operates is nothing but the weak dispersion force, or what do we call as London force. London actually comes from the name of the person, Fritz London, who calculate the magnitude of this force. Okay. Polar, it's dipole-dipole force of attraction or dipole-dipole interactions. And for hydrogen bonded molecular solid, it is nothing but hydrogen bonds. Examples, all those solids which will have dipole moment equal to 0, H2, Cl2, I2. So all this homonuclear diatomic molecule, no, having the same atom, are all considered as non-polar. That does not mean that others are not. In such cases also CH4 are also non-polar, okay, because the net dipole moment of the system is always equal to 0. Considering the polar molecules, you have HCl, SO2, okay, they have net dipole moment. And considering the hydrogen bonded, you can clearly see oxygen is bonded to hydrogen, nitrogen is bonded to hydrogen. Okay, so they are having hydrogen bonded to electronegative element and small in size. So that is how we can categorize molecular solids. Okay. Then coming for the third category, that is metallic solid. So as I have told you, when anyone say metallic solid, don't get confused and say that metallic solids are made up of metals. They are not made up of metals. In case of metals, the constituent particles are positively charged metal ions and free electron. Always remember that the constituent particles are positively charged metal ions and free electron. The question is from where we are getting this positively charged metal ion and free electron. Always remember that. How do we define metals? Metals are those elements which have low ionization enthalpy. For those who don't understand what is ionization enthalpy is the energy required to remove the most loosely bound electron from an atom in its gaseous state and in its ground state. So in very simple words, the energy required to remove the last electron from a particular gaseous atom. Now try to understand. Whenever we talk about metals, metals are those systems which can give electron very easily. They will have very low ionization enthalpy. So what will happen? Since they have very low ionization energy, they can easily lose this electron. But these electrons will not go anywhere, but will remain in this crystals only, but free. This positively, once this metal lose this particular electrons, then what generates is a metallic cation. This metallic cations are nothing but known as kernels. So you'll have two constituents, metallic kernels and those electrons. Then this mobile electrons, these electrons will be free. That's why we call them mobile electrons, are simultaneously attracted by the positively ions. right? So these mobile electrons now are free. So it will be attracted by the metal ions. So electrons are negative, metals are positive. So they will attract one another. So when electrons and this metal will attract one another, they will become very, very strong bonding. Such bonding is known as metallic bonding. So metallic bonding is nothing but electrostatic force of attraction between free electron and nothing but the positively charged metal ions. So when they attract one another, such type of bonding is known as metallic bonding. Okay, which you can see in the figure. See, that is what happens. So in your particular fixed position, so there will be cations. Okay, you can see clearly the cations. And can you see this negative? These negatives are nothing but the electrons, and they are free. They will be moving around. And this negative will simultaneously attract all the positive cation towards itself. As a result, it will be very tightly bound to one another, which results in very, actually, result in very high tensile strength. Okay, they become very hard. Obviously, intermolecular force will be very strong. And what are the other properties a metal will have? They'll have very high electrical and thermal conductivity. Why they will have very high electrical and thermal conductivity, I don't have to tell you. Because of this free electron, if I put a potential difference on two ends, the electron can easily flow. They possess luster, they shine, right? And color in some cases. Now always try to understand, when anyone say color of a particular substance, is basically due to excitation of electrons. You have so many free electrons. So this electron, when actually in presence of light, when you actually give it light or energy, they go actually into excited state, and then they again come down to ground state. When they do so, they transmit some light, and that light actually is nothing but the shine or the color which you see. So basically, why metal possesses luster is nothing but due to the presence of free electron in them. They are highly malleable and ductile. Okay, why they are malleable? Why you can actually convert them into thin sheets, or why you can actually convert them into wires? Because if I'll actually push this down, also try to understand. If I'll try to move it from here, if I'll try to move it here, if I'll try to move it here, they can be easily moved. Why? Because they are not fixed. Wherever this metal ions will go, these electrons are free. So wherever it goes, it can attract them in that particular position only. So remember that these particular positions are not rigid. You can change them, because wherever they go, this electron can go and attract it. As a result, they can be easily be malleable and ductile. Okay, that is the property how a metal gets, okay, because of the presence of free electron in it. And finally, coming for covalent solids. So by the name itself, covalent solids, these solids are nothing but those solids where you will have covalent bonding. And remember that when we say covalent bonding is nothing but sharing of electron. And it usually happens between two non-metals. Okay, so covalent solids, the constituent particles are non-metals. Non-metals forms covalent bond. And these covalent bonds are exceptionally strong. And when they are strong, what happens is they does not break so easily. So what will happen is one molecule can attract another molecule will be bonded to another molecule. So what will happen? It can just go around with thousands and millions of molecules, and all can be bonded to one another. As a result, they will form a network of solids, okay, a network of bonds. And that's why these are also known as network solids, or sometimes known as giant molecules. They form big molecules because these covalent bonds are strong, which will not break so easily. Okay, and remember that since it is very strong, this covalent bonding, that's why this solid becomes very hard. Okay, some actually, that's why this kind of solids, or the category of the solid which comes in, or the types of solid, or the examples of solid which comes in this category is nothing but diamonds. What are diamonds? So basically, diamonds are nothing but those kinds, or one of the hardest material found in earth. Why it is so hard? It's because of such kind of network of bonding which is present, which holds them in their specific position and continues, okay, which becomes very tough, as a result of which they become exceptionally hard. But remember that in general, covalent solid becomes very poor conductor of electricity. Obviously, they don't have any free electron to conduct electricity. Okay, diamonds and graphites are one of the most common examples of such type of solid. But remember that there is an exception in covalent solid. Almost all of the covalent solids are very hard and they are very poor conductor of electricity. But except graphite. Graphite is very soft, okay, and it is a very, very good conductor of electricity. So that is one of the exceptions which you have in covalent solid. So that is all about your types of covalent or types of crystalline solids. So crystalline solids are basically of 4 types, which we call them as ionic, molecular, metallic, and covalent, depending upon the constituent particle and depending upon the nature of force present in them. Okay, so that is how we can understand it.